board. So new example. I mentioned the other day that I went to the store and I like to snack on nuts and raisins, among other things, and the mixed nut can I grabbed said, hey, we have less than 50% peanuts. I'm like, cool, I love other nuts too. But then I was wondering, is that really true? So we'll look at that claim in a minute based on some data I collected from my can of mixed nuts. Before that, what we're gonna do is we're gonna head over to stat key, and then confidence interval for a proportion, because the claim is that there's about 50% mixed nuts, or there's less than 50%, there's about 50% peanuts, or maybe less than 50% peanuts. When we start looking at a thing like that, that's a proportion, not a mean, but they behave similarly. So I'm gonna put this link in the chat to get you there quicker. For those of you watching this in the future. Okay, so there's the page I'm at in stat key, and it happens to be mixed nuts is at the top. Once in a while with problems in the book or homework problems I give you, I say, hey, go to this page, but then change the data set to something else. And if you ever have trouble finding a data set I mentioned, let me know and I'll point in the right direction. And so sometimes it'll be a different set of data that they have uploaded, but sometimes I'll give you the data and then you got to edit and paste it in like I did with the baseball players earlier. All right, so here, they have a sample from a mixed nut container, and in their sample, they took 100 nuts out of the can in some random way, and 52 of them were peanuts. So that means they get 52 out of 100 fraction, or 0.52 as a decimal, or 52%. So I'm just gonna write down that data. Example here. Oops, slides are out of order. All right, so we have a proportion. And we have a sample. And that sample is n equals 100. Our proportion, since it's from a sample, would be p with a little hat over it. And the proportion is always calculated by counting something and dividing by the total. So in this case, they counted 52 peanuts out of 100 nuts total. So a proportion could be a fraction, could be a decimal. They stated it that way also in stat key, and I could also state it as a percentage. So we have the option when we're talking about a proportion, we can talk about it as a fraction, a decimal, or a percent. And we definitely want to keep those straight. They each have their pros and cons. When I'm doing calculations, I think I prefer the decimal. When I am communicating with somebody about it, I think I prefer the percent. And then just sometimes a fraction is useful, and sometimes who cares. All right, some other things to consider. I mentioned before, whenever we look at a situation like this, we should consider population versus sample, parameter versus statistic. So what's my population here? Well, with lack of other information, it's like all cans of mixed nuts, I guess. They do reference this in the book somewhere, so I'd have to look it up to get the population exactly, but I'm just going to go for that. So all cans of mixed nuts. And the parameter would be the proportion of peanuts in a can of mixed nuts. I get, or proportion of peanuts out of all mixed nuts. Proportion of peanuts out of all mixed nuts, I guess. And often when I'm thinking about, when someone shows me a sample and tells me about their study, I gotta pause and think, now what is their population really? Who are they talking about? Is this broader than this? Oh, maybe this is only, you know, Captain Joe's peanuts that we're talking about here, not all possible mixed nuts. So this isn't always obvious, it requires some thought. Sometimes articles are good at stating, hey, this is definitely my population. I'm only concerned about middle-aged guys, like 40 to 60, that ride a mountain bike at least once a week. All right, anyway, so population parameter. Then I have a sample, right, from that population. And so that's what I have up here. I have a sample of 100 mixed nuts. And then I have a statistic, which is based on that sample, I made some kind of calculation. So this right here would be my statistic. And now what I want to do is I want to take that sample and statistic information and make a confidence interval. So I'm trying to find a confidence interval for the proportion of peanuts in all mixed nuts. In a moment, I'll simplify that a little bit. I got my mixed nuts at Bimart. They buy from a particular company. I think it's called Great Nuts, maybe. And so I'm just thinking about, okay, what proportion of peanuts do the Great Nuts mixed nuts cans have? So we'll look at that one next. All right, so let's make a confidence interval. So to make a confidence interval for a proportion, you need X, how many, and you need N, the total. So how many peanuts out of how many mixed nuts total? And I happen to be already given that. Once I have that in there, I just go generate 1,000, generate 1,000, another 1,000, another 1,000, another 1,000. And I usually do at least 6,000. Could I do 10,000? Sure. Might slow your computer down for a minute, but that's okay. So bam, this is a sampling distribution. I have 6,000 samples. Any point here is a sample of 100 mixed nuts based on the original one. So imagine we take those 100 nuts here and we put them back in a can, and you reach in, grab a nut, write down what it is, put it back in the can. Reach in, grab a nut, write it down, what it is, put it back in the can. You do that 100 times. That's one sample, right? So I did that 100 times. I write down, okay, I found there were 56 out of 100. Then I do it again. I reach into the can, I look at the nut, write it down. Reach in, look at the nut, write it down. Then I count. After I did that 100 times, how many were peanuts? Get your proportion. So StatKey repeated that experiment 6,000 times for me based on these 100 nuts. Made this sampling distribution. Then I click to tail, and StatKey says, would you like a 95% confidence interval? And I say, sure. So StatKey says, okay, your confidence interval is lower end 0.42, upper end 0.62. So based on this original sample, StatKey says that on average, with these nuts, you're going to find between 42 and 62% peanuts. And in the middle is the 0.52. Notice that's exactly the same as my original sample. And I mentioned before, sometimes that will be exactly the same in the middle. Sometimes it'll be a little bit different. You didn't see the nuts in the book. Yeah, I remember seeing it somewhere in there earlier. Pretty much any data set that's on the StatKey website is referenced somewhere in the book. It's just a matter of finding it. So I'll look again later. So there's my confidence interval. So usually what I do is I sketch this on a piece of paper next, or I copy and paste it here. I'm going to go for the sketch thing. I think I can remember those numbers. Notebook. All right. So I'm going to sketch my sampling distribution. And so usually for sampling distribution, I draw the x-axis, and then I draw my best symmetric bell-shaped curve, and everyone's a little different than the last. In the middle, StatKey says it was 0.52. Out on the left, StatKey said 0.42, and out on the right here, 0.62. And this is StatKey's version of a 95% confidence interval. The 95% is called the confidence level. And I made an interpretation of that earlier. I'll mention that again shortly. So if I want the margin of error here, remember, to get the margin of error, I have to take the upper end of the confidence interval, subtract the lower end of the confidence interval, and divide by 2. And I feel comfortable doing that without a calculator. So I get a margin of error of about 0.1 or 10%. So what StatKey is telling me is that it thinks the actual proportion, this parameter here, P, proportion of peanuts out of all mixed nuts, is somewhere between 42% and 62%. Another way to state that is that we think the true proportion, is within 10% of that middle of 52%. So I think the average is about 52% peanuts, and I'm within 10% of the actual answer. Now somebody might say, well, 10%, that's a huge margin. Yeah, it kind of is. Would you like a smaller margin? And they say yes. I said, okay, well, let's be less confident. So I could go over here and say, all right, fine, let's just be 50% confident. No, let's not do that. Let's do 80% confident. 0.8 is 80%. Okay, so now I can say my margin of error is more like about, what is that? 6% instead of 10%. That's better, but now I'm less confident about it. That kind of sucks. The only other thing I change is get more nuts. Grab 1,000 nuts instead of 100, and you get better results. You'll get a smaller interval. So if I just make it up and say, okay, I'm gonna go get 1,000 nuts, that would be my sample size. And then maybe it's a pretty similar sample to that one right there. So that would be like maybe 521 peanuts. So I hit OK. It says my sample proportion is 0.521, right, 52.1%. And then I generate thousands. And what I should see here is a much smaller margin of error. Now my interval is from 0.49 to 0.551. So the margin of error there is about 1.5%, right? Way smaller margin of error. Instead of 10%, I got the margin of error down to like 1.5%, maybe even less than that. How do you get a smaller sample size? If you want to stay confident, you have to get a bigger sample. And then a bigger sample costs more. Okay, let's do this again, but with a different set of data. So I have my data here from that can of mixed nuts I got at Bimart the other day. And right on the can across the front, it says, we claim, didn't say we claim, it says less than 50% peanuts in big bold letters, less than 50% peanuts. I got nothing against peanuts, but I was excited about all those other nuts in there, so I bought some. It was like Brazil nuts. Those are awesome. So I took 5 different samples from my can, and the can, how big was that? It was like 6 or 7 inches tall with like a 4-inch diameter. It was, you know, not huge, but not small. And I grabbed, it looks like 25 peanuts at a time. Is that true? What did I do here? Peanuts, others, peanut total. Oh, and then I started adding them up. I see what I did here. Okay, so I took 25 peanuts out of the can. So I had 11 and 14 for the 25. And then I took another 25 for a total of 50. That second sample of 25 was 9 out of 16. So notice I have different proportions going along here. But then I just kept adding them up. So after my 4th try here, out of 100 nuts total, 50 of them were peanuts. And then I did one more, so out of 125, 58 were peanuts. And then I calculate the percents over here. So let's go with my last one here. So I don't really need to share this, all this data with you. We're just gonna say we found 58 peanuts out of a total of 125. That's all StatKey needs to know for a proportion. If I was doing a mean, StatKey would need to know every single number. But here, all it needs are those 2. So this right here would be my X, my count. And this one right here is my N, my sample size. I just need those 2 numbers. So let's go over to StatKey and edit the data. And I found 58 peanuts with a sample size of 125. So if you want to try this in StatKey too, go for it. I think I posted that link just a moment ago to this page. And so StatKey says, okay, 58 out of 125 is 46.4%. Now remember, there's sampling variability. Every one of my samples was a little bit different. And these totals and percents here, these are cumulative. Meaning I'm adding them up as I go. So the cumulative relates to both of these here. So at first, with just 25, I had 44% peanuts. Then after 50, accumulating those previous 25, I was at 40%. I had another 25, 75 total. That put me up to 52% peanuts. Then it dropped down to 50% peanuts, and then all of a sudden it was 0.464. How many peanuts were in the can? When I took these 125 out of the can, I hardly noticed any were missing. So my guess is that was like maybe 5 or 10% of the peanut, all the nuts in my can, not 125. So it's a relatively small sample compared to my population. It's probably like the baseball player thing. Maybe there were like 1,000 or 1,500 nuts altogether. I only looked at 125 of them as randomly as I could. Okay, so I want to make a confidence interval for this by mark can of peanuts. So I enter my sample data, and again, I just went to edit, put the count. I found 58 peanuts out of a sample size of 125. And then I just start generating thousands and thousands of samples, and usually 6,000 is enough. This right here is a sampling distribution. Sampling distribution has a mean of 0.464, which happens to be the same as my original sample. It's not always exactly the same, but they should be pretty similar. I'm going to go for a 95% confidence interval. And so let's see, Stackey says that based on this sample, we think the true proportion of nuts in Bi-Mart's mixed nuts cans that claims to have less than 50, we think it's somewhere between 37.6% and 55.2. So new sketch here, new situation. Oops, that button right there. So my population here is Bi-Mart's mixed nuts that claim less than 50% peanuts. And if you go to a Bi-Mart anytime soon and check out their snack section, I bet you'll see this one. I think it's a big red label on there that says, hey, we got less than 50%. Okay, so that's my population. My parameter, P in this case, because it's a proportion, mu would be for a mean. My parameter is the percent of peanuts. Percent or proportion peanuts. I took a sample. One of their cans, from one of the cans, I grabbed 125 nuts. So Gary's sample, N equals 125. And Gary found that there were X 58 peanuts in that 125. And so my statistic, in this case, we would call P with a little hat over it. That would be the 58 over 125, which Stack P claims to be about 0.464. I'll check that on my calculator. Probably got more decimal places than that, but they just rounded to 3. My calculator says, oh, that's 0.464, cool. And so often, like the decimal will be sometimes messy, so we just have to decide where to round. And usually I go to like 1/10%. So if you think about that as a percent, that would be 46.4%. So there's my 1/10%, which I go for, unless it's some weird situation where I need more decimals. Like incidence rates for things like diseases tend to be, very small percentages, less than 1%. All right, so next is my confidence interval. So I'm going for a 95% confidence interval, CI, and sketching that out, I got a mean of 0.464. That's my estimate of P based on my P hat, right? So that's the idea of a point estimate. Point estimate. And so that means I'm saying that the actual, real, true of all the peanuts that this company made, all the mixed nuts this company makes, I think it's about equal to my sample, which was that 46%. Oops. That's called a point estimate. And then from the point estimate, Stackey helped me find an interval estimate. And Stackey said 37.6, 55.2. I have an interval estimate. And then we'll get the margin of error and explain what this interval means. So the interval estimate would be parentheses 0.376, comma 0.552. And in the online homework, just pay attention to whether it asks for a percent or a decimal. So sometimes it'll be, you just type something like that in a box. Sometimes you'll see something like a box, percent, less than P, less than box, percent. So if that were the case, I would enter 33 or 37.6 because they have the percent symbol outside, and 55.2. So pay attention to the fine print. Does it want an interval? Does it want numbers? Does it want percents? Does it want decimals? Margin of error, if we wanted to include that here too. And usually I put that with the point estimate, but you could put it with the interval too. But usually I don't ask for all at the same time, just one or the other. Point and margin, or lower and upper. So that would be the upper 0.552 minus the lower 0.376 over 2. Do we get 0.376 minus 0.552? Put this in the wrong order. That's okay. It'll just set the wrong sign. Divided by 2. I get, if I type them right, 376, 552, 0.088. As a percentage, that would be 8.8%. Oops, place. So point estimate, margin of error. So another way I could state my answer is p hat plus or minus the margin of error. So that would be 0.464 plus or minus 0.088. All right, what does it mean? I am 95% confident, this is the interpretation, that I'm going to write percent instead of proportion. So I'm going to go over to ByMart and say, hey, check this out. 95% confident that the percent of peanuts in these mixed nut cans, these being whoever made those nuts, these mixed nuts cans is between 37.6% and 55.2%. Oops. All right, so question. Is 50% in my interval? Answer, yeah. So is there a chance that their claim is incorrect? The answer is yes. There is a chance this is incorrect because 50% lives somewhere over here. 0.5 is 50%. That's in my interval. So could it be that they have actually 50% peanuts instead of less than? The answer is yeah, that could be. Could it be they have more than 50% peanuts? Yeah, that could be too. Could it be I just have a weird can or a weird sample? Yep, that could be true too. So what's the truth? I don't know. All I know is I'm 95% confident that based on this sample, there's between 37.6 and 55.2% peanuts, making their claim questionable if I think I did good work, 1, choosing the sample, and 2, making my calculations. Now, I'm confident in my ability to use StatKey to make these calculations, so the only questionable thing here is my can and my sample. Right? So I should go back to ByMart, buy another can, take another sample. Maybe I'll do that this week, and we'll look at this again next week.